Protostar. Protostar. Imagine a giant, messy cosmic nursery. A swirling cloud of hydrogen, helium, gas, and dust, the size of dozens of light years, lazily collapsing under its own gravity like a reluctant college student finally getting out of bed. This is a protostar, the earliest awkward teenage phase of a star's life. Pressure in the core skyrockets, heating things up to over 1 million degrees Celsius. It's getting hot, but not hot enough for nuclear fusion yet. The protostar hasn't turned on the lights. It's basically a star with commitment issues. Most form inside stunning stellar nurseries like the Orion Nebula. Think glowing, colorful clouds that look like a fireworks factory exploded in slow motion. As it spins faster, a glowing disk forms around it. The same kind of spinning frisbee that will eventually birth planets, moons, and asteroids. Our entire solar system started as one of these chaotic, violent rotating pancakes 4.6 billion years ago. Red dwarf. Red dwarfs are the quiet, reliable introverts of the universe. They're the smallest and most common true stars, yet so dim you can barely see them without a telescope, like that hardworking friend who never posts on social media. They're only 10 to 50% the mass of the sun. Imagine shrinking our sun down to the size of a beach ball and shine with less than 1% of its brightness. Surface temperature. A relatively cool 2,500 to 4,000 degrees Celsius, giving them a dim reddish glow. But don't let the small size fool you. Young red dwarfs are drama queens. They unleash insane stellar flares that can strip atmospheres off planets like peeling paint. Some flares release more energy in minutes than all of human civilization has used in history. They burn fuel so slowly they'll live for trillions of years. The universe itself is only 13.8 billion years old. Red dwarfs are basically immortal compared to that. They'll probably be the last stars still glowing when everything else has faded into silent red embers. Yellow dwarf. Yellow dwarfs are the golden middle children. Stable enough to raise life, but dramatic enough to remind you space is never truly chill. Our sun is one. Every second it fuses 600 million tons of hydrogen into helium. That's like converting the weight of Mount Everest into energy. Constantly. From space, the sun actually looks white, not yellow. Earth's atmosphere just makes it look warm and golden, like putting an Instagram filter on a star. Surface, 5,500 degrees Celsius. Core, a terrifying 15 million degrees. It's already 4.6 billion years old, halfway through its stable life. One day, it will swell into a red giant and cook the inner planets. Every beautiful sunrise you've ever seen? Just a temporary phase. The sun's politely counting down while giving us life. Blue giant. Blue giants are the flashy, short-lived rock stars of the cosmos. Born ridiculously massive, 10+ times the sun's mass. They burn fuel like a billionaire burning cash in Vegas. They shine hundreds of thousands to 1 million times brighter than the sun, turning nearby space into a radiation storm. Surveyed temperature, over 30,000 degrees Celsius. Hot enough to make the sun feel like a lukewarm cup of coffee. They live fast and die young, often lasting just a few million years. Cosmic mayflies. But they do something beautiful. They cook up heavy elements like oxygen, carbon, and silicon in their cores, the raw ingredients for planets and life. Then they dramatically explode as supernovae, briefly outshining entire galaxies. Extravagant to the end, red giant. Red giant. After billions of years of stable life, stars like our sun eventually hit their midlife crisis and swell into red giants. The core contracts while the outer layers balloon outward dramatically, like someone who quit the gym and ate everything in sight. Some grow so enormous they could swallow Mercury, Venus, and even Earth whole. Though cooler on the surface, around 3,000 to 5,000 degrees Celsius, they shine much brighter because of their gigantic size. Inside, helium fusion begins, creating carbon and oxygen, the same elements in your body right now. A large part of the carbon in your cells was forged inside ancient red giants. The universe literally recycled dead stars to build you. This temporary but dramatic phase marks the beginning of the end for medium-sized stars. Supergiant. Supergiants are the true giants of the universe, absolute monsters that make the sun look tiny. Some are over 1,000 times wider than the sun. If one replaced our sun, it would extend beyond Jupiter's orbit. These massive stars fuse elements all the way up to iron like mad scientists. But once iron appears in the core, fusion stops producing energy, it's game over. The core collapses in seconds, triggering a supernova so bright it can outshine an entire galaxy. From these violent explosions come the heavy metals that form rocky planets, cars, phones, and even your bones. Supergiants live fast, die young, and leave behind the essential ingredients for new worlds and life. Wolf-Rayet Star. Wolf-Rayet stars are massive stars in the middle of a dramatic self-destruction. They violently blast their outer layers into space at millions of kilometers per hour, like a star having the most explosive breakup imaginable. With surface temperatures over 50,000 degrees Celsius, they expose their glowing cores and spew carbon, nitrogen, and oxygen across the galaxy. These rare, extremely luminous stars are highly unstable and shine hundreds of thousands of times brighter than the sun. Most will end in powerful hypernovae or gamma-ray bursts capable of sterilizing planets light years away. Wolf-Rayet stars are the universe's clearest examples of stars losing control and entering full self-destruct mode. White dwarf. White dwarf, after a red giant sheds its outer layers, what remains is a white dwarf, a dense stellar corpse. It squeezes the sun's mass into a sphere the size of Earth. A single teaspoon of its material would weigh several tons on Earth. No longer undergoing fusion, it glows only from leftover heat, like a dying ember. Young white dwarfs are extremely hot, but they slowly cool over billions of years. The universe is still too young for any to have become black dwarfs. Some steal matter from companion stars and explode as Type Ia supernovae. Even dead stars can still throw one final, dramatic tantrum: neutron star. Neutron star, when a supergiant explodes in a supernova, its core collapses so violently that protons and electrons fuse into neutrons. The result is a neutron star, more massive than the Sun, yet only about 20 kilometers wide, roughly the size of a city. A teaspoon of neutron star material would weigh billions of tons. They spin dozens to hundreds of times per second and have magnetic fields trillions of times stronger than Earth's. Falling onto one would stretch and destroy you at the atomic level. Neutron stars push matter and physics to limits that feel almost impossible. They are the universe after total collapse. Pulsar. Pulsars are rapidly spinning neutron stars that work like cosmic lighthouses. As they rotate at incredible speeds, powerful beams of radiation shoot from their magnetic poles. When these beams sweep across Earth, we detect precise, repeating pulses. Some pulsars spin over 700 times per second. The first one, discovered in 1967 by Jocelyn Bell Burnell, had such regular signals that scientists jokingly called them LGM, little green men. For a moment, humanity thought we might have found aliens. In reality, it was just a dead star screaming across space in perfect rhythm. Pulsars are exploded stars that refuse to stay silent. Magnetar. Magnetars are the final bosses of neutron stars, the most magnetic objects in the universe. Their magnetic fields can be 1,000 trillion times stronger than Earth's. If one appeared between Earth and the Moon, it could erase data from every device on the planet and distort atoms themselves. Occasionally, their crust cracks in violent starquakes, releasing more energy in a fraction of a second than the Sun produces in thousands of years. Small but extremely powerful, magnetars are the cosmos's natural doomsday weapons. Their extreme magnetism fades after about 10,000 years, turning them into quieter neutron stars. Black hole. Black hole. When the most massive stars collapse, gravity wins completely. Nothing, not even light, can escape, creating a black hole. At its center lies the singularity, where density becomes infinite and physics breaks down. Around it is the event horizon, the point of no return. Time slows dramatically near black holes. Some are quiet, while others devour stars and blast powerful jets across thousands of light years. From fragile clouds of gas to objects that bend reality itself, this is the full, mind-blowing journey of stars. Black holes are the ultimate cosmic ending, so which one unsettled you the most? The immortal red dwarfs that will outlive the universe, the city-sized neutron stars, the reality-bending black holes, or the dramatic Wolf-Rayet stars that literally tear themselves apart? Drop your answer in the comments. Like, subscribe, and let's keep exploring the terrifying, beautiful, and slightly unhinged universe together.